Ever pondered why the sky is blue? Could it be a different color, or is it all just an illusion? Welcome to the fascinating world where we'll delve into the mysteries of the cosmos, beginning with our very own sky. It's a question that sparked curiosity for centuries. A simple glance upwards and we're confronted with an azure expanse. But is it truly blue? Or are our eyes playing tricks on us? Many of us grew up believing that the sky is blue because it's reflecting the ocean's hue. Others might say it's just a backdrop for the sun, moon, and stars. But these are common misconceptions, tales spun from a lack of understanding. The truth, as you'll discover, is far more complex and interesting, a blend of science, light, and atmospheric phenomena. So strap in, cosmos explorers. Stay tuned as we unravel the mystery behind our blue sky. Colors, they are not just about aesthetics, they are the result of complex scientific phenomena. Let's dive into the science of colors. You see, light isn't just light, it's a spectrum of colors, each with its own specific wavelength. Imagine a rainbow. Each color you see, from the red at one end to the violet at the other, represents a different wavelength of light. Red has the longest wavelength while violet has the shortest. But what about sunlight? Isn't it just white light? Well, that's where it gets interesting. Sunlight, while appearing white to our eyes, is actually a mix of all the colors of the rainbow. This mix, known as the sunlight spectrum, is crucial to understanding why we perceive the sky as blue. Here's the deal. When sunlight enters our atmosphere, it interacts with air molecules and particles in the sky. This interaction causes the light to scatter or spread out in all directions. And because each color has a different wavelength, they scatter differently. So, why don't we see a rainbow-colored sky? That's because shorter wavelengths, like blue and violet, scatter more than longer ones, like red and orange. This scattering phenomenon is called Rayleigh scattering, named after the British scientist Lord Rayleigh, who first studied it. So, if colors are about wavelengths, how come we see the sky as blue and not red or green? Enter the realm of Rayleigh scattering, the real blue maker. Let's dive into this fascinating phenomenon named after the British scientist Lord Rayleigh. In the late 19th century, Rayleigh proposed a theory to explain why the sky appears blue to us. This theory is based on the scattering of light, particularly how shorter wavelengths scatter more than longer ones. But what does that mean exactly? Well, imagine light as a cluster of waves, each with their own distinct length. The sun emits light in all visible wavelengths, including the shorter blue and violet wavelengths, and the longer red, orange, yellow, and green wavelengths. When sunlight enters our atmosphere, it collides with the tiny oxygen and nitrogen molecules that make up the air. This collision causes the light to scatter in different directions. The key point here is that shorter wavelengths, like violet and blue, scatter more than longer ones. This is because their smaller size allows them to interact more with the tiny air molecules. Now you might be wondering, if violet light is scattered more, why isn't our sky violet? That's an excellent question. Even though violet light is scattered more, our eyes are less sensitive to it. The cells in our eyes, called cones, are more sensitive to blue light. Additionally, sunlight reaches us with less violet to start with. So the blue scattering dominates our perception, and voila, we see a blue sky. But it's not just about the color blue. This scattering also explains why the sky changes color at sunrise and sunset. As the sun moves closer to the horizon, its light has to pass through more atmosphere, which means more scattering. The shorter blue and violet wavelengths are scattered out of view, and the longer wavelengths like red, orange, and yellow become more visible, painting the sky with the warm hues of twilight. So, the sky isn't blue because it wants to match with your eyes, but because of a phenomenon named after a British scientist. But wait, is the sky always blue? Not quite. At sunrise or sunset, a breathtaking transformation occurs. The path of light through our atmosphere changes, painting the sky with a brilliant palette of reds, oranges, and purples. Our sky is more than just a blanket of blue, it's a cosmic canvas of shifting shades and hues. So next time when you look up, remember, it's not just a sky, it's a science spectacle happening right above.